Hey friends, so I realize I forgot to record the intro to this video. So basically, one of our students in our sixth period Blue Day was able to bring in a deer heart and a deer eye for Mrs. Steele to dissect. While the other classes, we took you all out to the creek to build an ecosystem. So we wanted to record this for this Farm Fresh Friday to give you all kind of an inside look into a deer heart and a deer eye, which is super cool. And I wanted to come on here and just say there is a little bit of blood. So if you tend to be a little bit squeamish, I just wanted to make sure everyone had a little warning before the start of this video. So here's a picture of a sunset that I took the other day for you all to listen to me talk. Anyway, we'll get right into the video.
So we look at the deer heart because the deer heart is very similar to human heart, okay? So that's why we brought it in the past. I've got a diagram up here which shows all of the parts of the heart, and then you'll be able to see what I'm doing right here. Now, a few things that you may not know, or a few fun facts about the heart is that the heart is essentially a muscle. So if you look at all this tissue right here and all of this, that is all muscle tissue. And then you have fat, just like on any other part of the body. And then you have these ventricles that are kind of like canals for the body, for the blood to go in and out. So if you look at the diagram here, there's four major hemispheres of the heart. There's the right ventricle, the left ventricle, the right arteriole, and the left arteriole. And we can see those very clearly on the heart itself here. So if you look, it's the left and the right ventricle, and then the arterioles are up here. And then you've got all these valves, like the aortic valve right here, which I'm sticking my finger in right now, that is the canal for how the blood travels through the body. And so I thought it would be kind of interesting if I showed you kind of the directionality of where the blood flows. So if you look right here, we have lungs, we have all these other organs that have to have blood flow to survive. Blood is like the oil in an engine, okay, in your car. If you don't have the oil, the engine blows up. It's not able to live, right? So our body's much the same way. Blood has to flow to muscle tissue to keep it living. As you can see, this is not really pretty red anymore. It's starting to kind of turn brown, and you'll see like right here, it's starting to turn really dark. If the muscle doesn't have that warm blood pumping to it, the tissue starts to die and it becomes very hard and black. So eventually, if we don't put any kind of preservative with this, then this would turn really, really hard and rubbery like, and eventually that tissue would die. That's how we, decompose as a human. So we're going to be using today some isopropyl alcohol, which you find in any drugstore, to help preserve it a little bit longer, but not as long as things like formaldehyde. But it also doesn't smell and stink and coat as much as formaldehyde. So we'll be able to put this on the shelf back there all year for you to visualize and see the heart.
Cool.
So anyways, like I was saying, the blood has to flow in and out of different parts of the body to continue to feed that muscle tissue. So we have kind of a gateway or a ventricle that goes to the lungs and from the lungs. So this is the way it comes in from the lungs, and then it'll come out of this ventricle, which is the left pulmonary artery, to the lungs. So that feeds the lungs that blood tissue that blood it needs for the tissue to survive. The rest of the body comes in this way, and then it'll come out the aortic valve. And that's why the aortic valve is so much bigger, because it's supplying the rest of the body with blood. This is smelling great. So we can look at this, and it smells really, really, well, it smells like warm blood, really. But if I push it, you can see that the muscle of the heart can contract and come back. So it's very, very pliable. And that's because the heart pumps. So if you've ever heard of, people that have quadruple bypass surgeries and things like that, where they bypass some of these ventricles with other kind of tubes, man-made, or pigs actually is another one. Pig valves are really popular these days. But the reason they do that is so that the heart can continue to be pliable and pump. So if you put your hand over your chest right now, you can actually feel your heart contracting and pumping like it does. That's what it's doing inside your body. So that pumps that blood out of those arteries and into other parts of your body. And then that continuous flow is what causes the blood to come back to your heart. So it's pretty cool. I'm gonna go ahead and I'm gonna slice in between the left and the right, just so that you can see kind of the makeup of the inside. So your body, inside your body, this is the gateway that your blood travels through. So essentially what happens is when you guys eat all that fatty food and Doritos and processed stuff, what can happen is blood platelets will kind of stick to the edges of this, the inside edges of this, and it will restrict the blood from flowing in it. So it's almost like it shrinks that hole, so it makes your heart have to work twice as hard to pump through it. So that's why it's important you eat heart healthy food. But look at all of these little veins and things that feed the tissue in the heart. Isn't that neat? That is so neat. Oh, you can see really good up here. See that? You see all those little veins?
Yeah.
That's feeding the heart tissue the blood it needs. Is because it, unlike the heart, it's so different than the human eye. Okay? Now you all know you have a hole in your eye, right?
Oh, yeah.
Yeah. Who said no? You're not the only person that did not know that. Fun fact for you, about a couple years ago I had a whole class that did not know they had a hole in their eyeball. But we have that opening in our eyeball because it will get bigger or dilate, and then it'll get really, really small to allow different amounts of light into your eye, okay? Helps you see better at night or during the day. It's not that much different, but there are some notable differences, like the shape of the pupil, which you'll see in a minute when I put it on my finger. The shape of the pupil in a deer looks kind of like a slit or an oval opening. In a human, if you look at your neighbor's eye, don't get too close, but you'll see this black circle, and it's a perfect circle. That is your pupil. So it's a different shape altogether. Now the reason why that's important to note is because that's why deers are able to see better at night than we are, okay? Because it allows a certain amount of light to come in, and it's able to reach that back part of the eye called the retina. Now the deer also, fun fact for you, can only see yellow and blue light. They can only see those two colors. Jello-like little sphere, it almost looks like a marble, but it's very pliable, so you'll get to squeeze on that some too. They're all connected to the body by what's called an optic nerve. So it's a big bunch of nerves. It's not actually just one, it's a bunch of nerves that feed signals to your brain that tell your brain the sharpness. If you've ever looked at the inside of a magnifying glass, or not magnifying glass, oh, there it goes. All right.
Oh, that's amazing.
So that's the lens. Oh,
Wait, yeah.
That's the lens. It almost looks like a
jellyfish.
water droplet, right?
Kind of looks like a jellyfish.
That lens works as a convex lens. See how I wrote that up there? To magnify things. So if we actually roll this over some print, it would appear bigger, slightly bigger. So that's the same as if we look under the microscope, there's these harder glass lenses that actually, actually bend the light. So that's what this lens does inside the deer's eyeball. So you want to touch it?
Can I touch
It's
it?
pretty cool. It's not round like ours, it's slit. And you can't see it real good with me pushing my finger on it, because when I push my finger on it, it kind of looks round, but it's not. It's more that way. And then you can see around it is the iris. I was trying to show you this down here. The very back, that retina is the prettiest blue. I don't know if that's coming across.
Oh, that is a pretty blue.
That right there, do you see that?
That's so pretty.